So in this video, I'm going to go over problems 3 through 10 from your worksheet. Problem number 3 says you have 0.10 moles of aluminum nitrate. This compound contains how many nitrogen atoms? So we start off by saying that you have 0.10 moles of aluminum nitrate. You always start off by whatever they give you. And then we know that for every mole of this compound, so for 1 mole of aluminum nitrate, how many moles of nitrogen do you have? So if we look at this, for 1 mole of aluminum nitrate, you have 3 moles of nitrogen, because there are 3 nitrogens in this compound. So for every 1 mole of aluminum nitrate, there are 3 moles of nitrogen. And then we know that for every 1 mole of nitrogen, since we're converting from moles to atoms, we're going to say that 1 mole of nitrogen contains how many atoms? 6.02 times 10 to the 23rd, which is Avogadro's number. And in this case, we're going to say atoms. So you start off by saying you have 0.10 moles of aluminum nitrate. For every 1 mole of aluminum nitrate, you have 3 moles of nitrogen. For 1 mole of nitrogen, you have 6.02 times 10 to the 23rd atoms of nitrogen. So then you plug this into the calculator, and you should be getting 1.8 times 10 to the 23rd. So this is your answer. Number 4 says you have 0.100 moles of ammonium dichromate, and this contains how many grams of nitrogen? So again, you start off by whatever information they give you. So 0.100 moles of ammonium dichromate. So we write 0.100 moles of this compound. So we do essentially the same thing we did before. So for every 1 mole of this compound, I'm just going to say compound X so this is going to turn into X, just to shorten it. So for every 1 mole of compound X, you have how many moles of nitrogen? So nitrogen is our focus here. So how many moles of nitrogen do we have? We have 2, because there are 2 nitrogens. So for every 1 mole of this compound, we have 2 moles of nitrogen. And then since we're going from moles to grams, we're not going to use Avogadro's numbers like we did before. We're going to say, okay, well, for 1 mole of nitrogen, we have how many grams of nitrogen? So we would go to the periodic table and determine that for every 1 mole of nitrogen, there are 14 grams of nitrogen. And then we would put this in our calculator, and you should be getting 2.80 grams of nitrogen in this compound. So we start off by writing whatever information they give us. So 0.100 moles of this compound. For every 1 mole of this compound, we have 2 moles of nitrogen. Why are we writing nitrogen? Because that's the element that they're asking us about. And then for every 1 mole of nitrogen, we have 14 grams of nitrogen according to the periodic table. Okay, so question number 5 says, what mass of copper carbonate contains 100 grams of copper? So in this question, basically what we have to do is test out each of the answer choices that they give us. So choice A says that we would start out with 358 grams of this compound. So the question we need to ask ourselves is, if we start out with this much copper carbonate, are we going to end up with 100 grams of copper? So to test that out, we have to say, okay, so we start off with this. The molar mass of this compound is 221. So 221 grams. And we're putting that one on the bottom because the units have to match up on the top and on the bottom so that they can cancel out in the end. So for every 221 grams of copper carbonate, we have 1 mole of copper carbonate, correct? And for every 1 mole of copper carbonate, how many moles of copper do we have? 2, because we have 2 coppers. So for every 1 mole of copper carbonate, we have 2 moles of copper. Now, for every 1 mole of copper, we have how many grams of copper? If we go to the periodic table, we should have 64 grams of copper for every 1 mole of copper. So notice how these units are going to cancel out. Grams of copper carbonate, grams of copper carbonate. Now moles of copper carbonate and moles of copper carbonate cancel out. And now moles of copper and moles of copper. So this leaves us with grams of copper. So if we put this in the calculator, we would get, let's see, how many grams of copper? So 358 divided by 221 times 2 times 64. So we would end up with 207 grams of copper. So it is not, our answer is not going to be A. We end up with more than we need. We need 100 grams. So answer choice B says that we would start with 174 grams of this compound. Okay, so we do the same thing. So instead of starting off with 358 grams, we're going to start off with 174 grams. So let's do the same thing. Instead of writing out the whole compound, I'm going to write X. So we put this over 1. And then we do the molar mass of compound X is 221 grams. For every mole of copper carbonate, we have these many grams, right? Now, for every, or in other words, for every 221 grams of this compound, we have 1 mole. For every 1 mole of this, we have how many moles of copper? 2. 2 moles of copper. And for every 1 mole of copper, we have 64 grams of copper. So we're doing the same thing. We start out with 174 grams of copper copper carbonate. And then we say, okay, for every 221 grams of copper carbonate, we have 1 mole. For every 1 mole of copper carbonate, we have 2 moles of copper. And for every 1 mole of copper, we have 64 grams of copper. So if we put this in the calculator, we should say 174 divided by 221 times 2 times 64 equals 100 grams of copper. So this should be your answer. So it's just a matter of testing out your answer choices in this case. Okay, question number 6 says, what weight of calcium carbonate contains the same weight of oxygen that 171 grams of aluminum sulfate contains? So this is a tricky question because they're asking us to compare the weights of oxygen in both of these compounds. Is there a way that we can figure out the weight of calcium carbonate? Not yet. Let's figure out the weight of aluminum sulfate first. So we start off with 171 grams of aluminum sulfate. Okay. Now, what is the molar mass of aluminum sulfate? They tell us is 342. So for every 342 grams of aluminum sulfate, we have 1 mole, right? 1 mole of aluminum sulfate. So far we have this. We started off by this piece of information that they give us here, 171 grams of this. We don't know the mass of this calcium carbonate. That's what we're trying to figure out, right? So we have 171 grams of aluminum sulfate. We know that for every 342 grams of aluminum sulfate, which is the molar mass, we have 1 mole of aluminum sulfate. Now, for every 1 mole of aluminum sulfate, how many moles of oxygen do we have? So 3 times 4 equals 12. 12 moles of oxygen. And then we have to figure out for every 1 mole of oxygen, how many grams of oxygen do we have? So this is 16 because the periodic table tells us that. So again, 171 grams. We start off with that. We know that for every 342 grams of aluminum sulfate, we have 1 mole of aluminum sulfate. And for every 1 mole of aluminum sulfate, we have 12 moles of oxygen. Because look, we have 4 oxygens here. So this would be multiplied by 3. So 12 moles of oxygen. And then for every 1 mole of oxygen, we have 16 grams of oxygen. So we would plug this into our calculator, and we should be getting... So the point of all this is to figure out how many grams of oxygen are there in 171 grams of this compound, okay? So we calculate this out and we get 96 grams of oxygen. So now we look at our answer choices here for question number 6, and we have to test them out, okay? So basically we need to say, okay, for let's just say A. A says that we would start off with 50 grams. So now we forget about this compound. We know that this compound has 96 grams of oxygen. So what mass of this compound now has the same mass as this, like 96? So we're hoping that if we start off with 50 grams of calcium carbonate now, we would get 96 grams of oxygen. So let's see. So we put 50 grams of calcium carbonate over 1. For every 100 grams of calcium carbonate, we have 1 mole of calcium carbonate. Okay? And for every 1 mole of calcium carbonate, we have how many moles of oxygen? 3 moles of oxygen. So 3 moles of oxygen. And for every 1 mole of oxygen, we have 16 grams of oxygen. Okay, so if we put this in our calculator, we hope that we get 96 grams of oxygen, right? Because that's the number that we're looking for. So we put 50 divided by 100 times 3 times 16. So this gives us 24 grams of oxygen. So this means that this is not our answer. Okay. Oh, and when you do when you set this up here, this is called stoichiometry. Make sure that your units on the top match the units on the bottom. So grams of calcium carbonate, grams of calcium carbonate, moles of calcium carbonate, moles of calcium carbonate, moles of oxygen, so that we're left with grams of oxygen here. Okay, so we determined that it's not A. How about B? So for B, the only thing that we would change is this value right here, our starting mass of calcium carbonate. That's what they're asking us about. So choice B says we would start off with 100 grams of calcium carbonate. Okay, so we start at 100 grams, and again we do the same exact thing. So for every 100 grams of calcium carbonate, which is the molar mass that they give us, we have 1 mole of calcium carbonate. For every 1 mole of calcium carbonate, we have how many moles of oxygen? 3. 3 moles of oxygen. And for every 1 mole of oxygen, we have 16 grams of oxygen. So let's see if this is gonna be our lucky winner. So 100 divided by 100 times 3 times 16, 48. Now look at something here. We didn't even have to calculate all this. If we knew that choice A said 50 grams and choice B says 100 grams, that's double. So we could just double the answer that we got here, 24, and we got 48 here. But anyways, that's not our answer choice. Our answer still. So let's move on to choice C. So again, all you're doing is you're changing the initial value. So in this case, we're going to use 171 grams of calcium carbonate. For every 100 grams of calcium carbonate, we have 1 mole of calcium carbonate. For every 1 mole of calcium carbonate, we have 1 mole of oxygen. 3 moles of oxygen, 3 moles. And for every 1 mole of oxygen, we have 16 grams oxygen. Now let's see. 171 divided by 100 times 3 times 16, 82 grams of oxygen. So we're getting close, but it's still not our answer. We need 96. We need 96 grams of oxygen, okay? So C gives us 82. So if we know that answer choice C gave us 82 grams of oxygen, do you think our answer is gonna be choice D, 25, starting with 25 grams? There's no way, because that would be a much lesser value, lesser weight of oxygen. For A we started off with 50 grams, of calcium carbonate, and that gave us 24 grams of oxygen. There's no way that starting off with 25 grams, we're gonna get 96 grams of oxygen. So we could rule out choice D, and we could move on to choice E. So let me just write it here on the back. So choice E says that we start off with 200 grams of calcium carbonate. Okay, so the molar mass of calcium carbonate is 100 grams per mole. Grams per 1 mole of calcium carbonate. And for every 1 mole of calcium carbonate, how many moles of oxygen do we have? 3 moles of oxygen. And for every 1 mole of oxygen, we have 16 grams of oxygen. So this should be our answer, because there are no more answer choices. So 200 divided by 100 times 3 times 16 equals 96 grams of oxygen. So this is our answer, choice E. Okay. Question number 7 says, a mole of a compound is composed of 6.02 times 10 to the 23rd atoms of hydrogen, 35.45 grams of chlorine, and 64 grams of oxygen. What is the formula of this compound? So, looking at this originally, this number is Avogadro's number. And we know that for every 1 mole, there are 6.02 times 10 to the 23rd atoms, okay? So this means that we have one hydrogen atom. Now, they give us 35.45 grams of chlorine. Okay, if we go to the periodic table, we need to determine how much does chlorine weigh. So it tells us that it weighs exactly this. So 35.45 grams of chlorine, that's just 1 chlorine. And then we have 64 grams of oxygen. How many oxygens is that? So we know that 1 oxygen weighs 16 grams, okay? So this means that 64 divided by 16 equals 4. So we have 4 oxygens. So your formula is going to look like 1H, 1 chlorine, and 4 oxygens. Question number 8 says, a sample of a compound has 0.66 moles of nitrogen. Let me highlight this. .667 moles of nitrogen atoms, 2.688 grams of hydrogen, 2.01 times 10 to the 23rd chromium atoms, and contains half as many oxygen as hydrogen atoms. What is the empirical formula? Okay, so when you're given questions like this, the most important part is to find the moles of each element. Okay, so we already have the moles of nitrogen. So moles of nitrogen is 0.667 moles of nitrogen. Okay, so we don't have to even touch it. Now we have to figure out how many moles of hydrogen are there in 2.688 grams of hydrogen. So to do this, we're gonna do, so let me do bullet points right here. So 2.688 grams of hydrogen. So what is the molar mass of hydrogen? 1.008 grams of hydrogen. For every 1.008 grams of hydrogen, how many moles do we have? 1 mole. And that's all you have to do to find the number of moles in this much hydrogen. Okay, so then you would divide that, and you get 2.666 moles of hydrogen. Okay, so we have moles of nitrogen, moles of hydrogen. Now how about moles of chromium? So in this case they're giving us the number of atoms. So we do 2.01 times 10 to the 23rd atoms of chromium, sorry, of chromium. And we know that for every 6.02 times 10 to the 23rd atoms, there are how many moles? 1 mole. So 1 mole of chromium. Okay? And again, make sure that your units match on the top and on the bottom. So here, grams of hydrogen, grams of hydrogen. And you end up with moles of hydrogen. Atoms of chromium, you end up with moles of chromium. So then divide all this. Now here's something. So if for some reason you have trouble putting this in the calculator, you could just do 2.01 divided by 6.02. So let me just set this up as a fraction. So 2.01 times 10 to the 23rd, and then 6.02 times 10 to the 23rd, so you divide this out. So when we have exponents in a fraction, we're supposed to subtract them, right? So 23 minus 23, that's 0. So this immediately is canceled out. So we just have to divide 2.01 divided by 6.02, and that would give us 0.3339 moles. Make sure that you get an answer like this. Don't really recognize this scientific notation well, and it could give you a number like 3.3 or something like that, and that would be incorrect. So far we have 0.667 moles of nitrogen, 2.66 moles of hydrogen, 0.3339 moles of chromium. Okay, so let me just highlight these. So moles of nitrogen, moles of hydrogen, moles of chromium. Now here's the key part. You have to divide all of these moles by the smallest mole number that you get. So in other words, okay, so we would divide, so for nitrogen, hydrogen, chromium, and oxygen. Okay, let me just set it up like this so it's not confusing. So nitrogen, what we do is we take the number of moles, 0.66, divided by the least number of moles, which is 0.3339. Okay? And you put this in the calculator and you get you need to get a whole number. Okay? So it is 2. Now for hydrogen, you take 666 divided by the least number of moles, so 0.3339, and that gives you 8. If it doesn't give you an exact whole number, round it to the nearest whole number. Chromium, so chromium, it was this number, 0.3339, and divided by itself, because that is the least number of moles, and that gives you 1. And oxygen, they said it was half as many oxygen as hydrogen atoms, so we have 8 hydrogen atoms, so half as many as that is 4. So in the end, it should look like you have 2 nitrogens, 4 hydrogens, 1 chromium, and 4 oxygens. Now it doesn't look like any of our answer choices, but what you do is, so for example, choice A says, it's written like something like this. Let me write it in the back. So choice A says NH4 Cr2O7. So we know this is not our answer because it should be 1 chromium and 4 oxygens, right? But I just want to show you. So it's not going to say 2 nitrogens and 8 hydrogens. It's going to say like this. So here you still have 2 nitrogens and 8 hydrogens. Okay, so let's look at all the answer choices. And the only one that matches is B, because we have 2 nitrogens, 8 hydrogens, 1 chromium, and 4 oxygens. Okay, so it would be this one. That's our answer. Okay, now for the last two, number 9 says a molecular compound has the empirical formula C3H4OCl. The molecular weight could be. So this is the key sentence. Could be. Okay? They're not saying the molecular weight is, they're saying the molecular weight could be. Why? Because if you have, they're giving you the molar mass of this compound. And we know that molecular mass is however many empirical formulas we have. Right? So if we have one of these, its molecular weight is gonna be 91.52. Okay? How about if we have 2 of those? Then it would be 91.52 times 2, and that would give us 183.04. So this is our answer. So it's just a matter of multiplying, depending on how many of these do you have. If you have 1, it's gonna weigh 91.52. If you have 2, it's gonna be double of this. Okay, last question. How many total atoms are present in 265 milligrams of this compound? So notice how they give us milligrams, okay? In chemistry, we usually deal with grams. So it is important for us to convert that later to grams. So we start off with 265 milligrams. And we know that for every 1,000 milligrams, you have 1 gram, right? So this would be our conversion. Now, now we have to figure out the molar mass of this. They gave it to us right here. It is 378 grams of this compound. For every 378 grams of this, we have 1 mole. Of this compound. And then for every 1 mole of this compound, we have how many atoms? Avogadro's number, so 6.02 times 10 to the 23rd atoms of this compound. So make sure your units match, okay? Milligrams, milligrams, grams, grams, moles, moles, and you end up with atoms. What would happen if you didn't convert milligrams to grams? Your answer would be incorrect. Okay, so if you calculate all this together, you should get 4.22 times 10 to the 23rd as your answer. Okay? So always remember So let's say they didn't give us milligrams, they just gave us grams. So we wouldn't have to worry about that. Always remember that you need to put the molar mass on the bottom here if you're going to start with grams. So grams, molar mass, and you know, like it's just like common sense, you know, like for every 378 grams you have 1 mole. For every 1 mole you have these many atoms, because 1 mole equals 6.02 times 10 to the 23rd. Okay, so this is why we're using this number right here.